Right, the graph of f is given to the right as shown here. Find each of the following and explain why it does not exist. The limit of f of x as x approaches infinity. Right, as x approaches infinity, you can see the graph continues to approach 4. When x approaches -3 from the left, when you approach -3 from the left, you can see the function approaches -2. When x approaches -3 from the right, you can see the function approaches y equals 0. Right, the limit of f of x as x approaches 4. Right, when x approaches 4 from the right, the function approaches 2. But when you approach 4 from the left, the function approaches 2. So it is 2 here. Right, so you have the limit of f of x as x approaches 0. As x approaches 0, from the right, the function is approaching infinity. From the right, but also from the left is approaching infinity. So that is what you have. Right, so when the limit of f of x as x approaches negative infinity, when x approaches negative infinity, the function approaches -1. If x approaches negative infinity, it approaches -1. The limit of f of x as x approaches 2. The limit of f of x as x approaches 2. Right, so you need to look very carefully and realize that x equals 2 is actually that is sort of a vertical line through which this function sort of continues to approach it from one direction. And so when we then say here that x approaches 2, what do we get? So you need to look very carefully and analyze these in C, because there are two parts, because 2 is this vertical line. So now if 2 is this vertical line, let's check what happens when x approaches 2. So obviously there are two instances. You can either approach 2 from the right or from the left. Okay, so if you approach 2 from the left, like so, then we have negative infinity. Right, so you have the limit as x approaches 2 from the left of f of x, you have negative infinity. The limit as x approaches 2 from the right. The limit as x approaches 2 from the right. Right, when x approaches 2 from the right, you can see that the function approaches 3. Okay, so we note that the limit as x approaches 2 from the right of f of x, this limit equals 3. Right, so here from the left, it actually is minus infinity. From the right, it is 3. So as a consequence, this limit here as x approaches 2 does not exist. Right, does not exist. So a couple of ways to say that. You can use this notation. You can say does not exist. Or you can write in full and say does not exist, like this. When x approaches -3, when x approaches -3, vi is 1, and just check 6. Let me just check this question carefully. It's 1. Need to comment very well here. So I think there are two parts to the question. So just a sec. Need to check this very carefully and make sure that we have answered the question in full, because otherwise then we shall be doing wrong stuff, or we shall be doing in the question that was not asked. Very likely it is x approaches 2 or 1. Okay, the image that was sent to me is too faint, but I'm going to comment on the fact that the limit is x approaches 1, right? Because x is 1. So there are two ways in which you can approach 1. From the left, the function approaches 3, but from also the right, the function approaches 3. So the limit of f of x is 3. Okay. Like this. V2. Now, the limit of f(x) as x approaches minus 2. This one here does not exist. Okay, let's check. Minus 3 is here. Because since we have two cases, since the limit as x approaches minus 3 of f of x from the left is minus 2, the limit as x approaches minus 3 from the right of f of x. Minus 3 is this one from the right. You can see that this function approaches 0. So yeah, this limit does not exist. Next. Right, now we're looking for the value of the function at 4. At x equals 4, the value of the function is 1. Okay. The value of the function is exactly 1 here. Right, if f of x is 3, then x equals what? Okay, if f of x is 3, so if y is 3, then what is x? Okay, x is clearly 1. Write down the equations of the horizontal asymptotes. What are the horizontal asymptotes here? Okay, so the horizontal asymptotes, there's this one and that. So the horizontal asymptotes, like this one, you can see this function continues to approach the line y equals 4. Right, moreover, this part of the graph approaches the line y equals minus 1 and does not reach it. Write the equations of the vertical asymptotes. The vertical asymptotes. What are the vertical asymptotes? Okay, so the vertical asymptotes will certainly be 2, because you can see that from the left and from the right here, these two functions approach the vertical axis and that not reach that. So one of the vertical asymptotes is certainly x equals 0, which is the y-axis. But now also, so you can say x equal to 0, which refers to the y-axis. Right, or this one here, which is x equals 2. Right, x equals 2 is sort of an asymptote as well, because the function approaches that and does not reach the vertical line. X equals 2. Okay, and we're done. And we're through. Okay, thanks everybody. Goodbye to you. A very goodbye to you.